to understand what atmospheric pressure is. Hopefully you figured out already. You know what the atmosphere is. The atmosphere is this envelope of gases that surround our Earth. So atmospheric pressure is the pressure which is exerted on the Earth by that envelope of gases, by that atmosphere. Our atmosphere is made up of gases, and gases have weight. It doesn't seem like gases have weight when we're just walking around in air all the time. But when you consider we have like 300 miles worth on top of us to the upper atmosphere of gas, that gas has quite a lot of weight, okay? Yeah, like we said, the atmosphere is about 300 miles thick. So when you have that much gas, that's going to have a significant amount of weight, even though gases don't have very high weights to begin with. They're not very high density, as we learned in last chapter. When you have 300 miles of it pushing down on you, that's quite a lot of force, right? Okay, generally, atmospheric pressure at sea level, the average atmospheric pressure at sea level over the Earth is just about 10.1 newtons per centimeter squared. So 10.1, so basically this equivalates to 101,000 pascals. Okay, 101,000 pascals, because this is newtons per centimeter squared, not meter squared. I don't know why I put it that way. Maybe that's something they use in chemistry. It was in your textbook. Okay, so this is the normal atmospheric pressure. Now, the atmosphere is made up of several different gases, as we've talked about before. The atmosphere is 78% nitrogen, 21% oxygen, and 1% some other things thrown in there. Carbon dioxide, argon, stuff like that. Okay? We know, because of something called Dalton's law, that the atmospheric pressure is equal to the sum of each individual pressure of these gases. What does that mean? Well, it means that 78% of the atmospheric pressure is due to the individual pressure of nitrogen gas. 21% of that total atmospheric pressure is due to the pressure, it's called a partial pressure, of oxygen gas. And I believe I've got a problem here on the next page that talks about it. Where are we in time?
2:45.
Okay, we'll continue then. All right, next page then. Let's talk about measuring pressure. Okay, so we use a barometer to measure pressure. Barometers measure atmospheric pressure, and it is generally based on the height of mercury in a glass tube. And so it is measured not just in pascals, but pressure is also measured in something called millimeters of mercury. All right, let's show you how this works. Here's a barometer. It's a very simple barometer, okay? And what we have is, this is mercury here on the bottom. And we have this glass tube inverted into this mercury. It's sealed at the top. And our air, our atmosphere in our Earth is pushing downwards on this mercury, just like it does on the top of your head and all around you. It's a whole envelope of gas. But the atmosphere is pushing downwards on this mercury. As that atmosphere is pushing downward on this mercury, a certain amount of mercury is pushed upward into this tube. And this tube is marked so that we can measure how many millimeters of mercury is the air pushing the mercury up into the tube. Okay? So the number of millimeters of mercury is a measurement of air pressure. All right? And that's why we can also say pressure is measured in millimeters of mercury. Okay, at sea level. Now we've already said at sea level we have an average air pressure of 101,000 pascals at sea level. Okay? In millimeters of mercury, however, at sea level, and if the temperature is 0 degrees Celsius, that's something called standard temperature, which you're going to have to know. We're going to get back to that. Our atmospheric pressure is 760 millimeters of mercury. Okay? All right, I think I'm going to skip the explanation of a manometer. There's a picture there, but we just don't have time. All right, so let's talk about these units that are millimeters of mercury. All right, these are just some other units that we use to measure pressure, and you should know them, measure atmospheric pressure. So 1 millimeter of mercury is also equal to something called a torr. Why we have to have all these units that mean the same thing, I don't know, but you need to know them for chemistry. Okay, so 1 torr is the same as 1 millimeter of mercury. So if the average atmospheric pressure at sea level is 760 millimeters of mercury, what is our average atmospheric pressure at sea level in torr? If you said 760 torr, you're correct. So that's what this is. All right, moving on. We can also measure pressure in terms of something called atmospheres. All right? 1 atmosphere is equivalent to that 760 torr. So 1 atmosphere is the amount of atmospheric pressure that is averaged over the whole Earth that is experienced at sea level. All right? As we've already described, oh, I thought I changed that, but I didn't. As we've already described, we also have pascals, which is the SI unit, abbreviated this way. 1 Pascal is 1 Newton per meter squared. And again, we can add our prefixes to that. So kilopascals means 1,000 pascals. So 1,000 pascals is 1 kilopascal. 1 atmosphere is equivalent to 1.01 times 10 to the 5th pascals, or 101 kilopascals, which was what we were saying, 101,000 pascals. You might have also heard of the pressure, this is the one that's used in the tires in your car, because we don't use the metric system here in the United States. They are PSI, which means pounds per square inch. And just for that conversion, we know that 1 atmosphere is roughly equivalent to 14.7 PSI, pounds per square inch, which is equivalent to 6.9 times 10 to the 3rd pascals. Unfortunately, yes, you have to know all these various units of pressure for chemistry. And you will have to know how to convert them. I will give you these numbers on the test, but you will have to know how to convert them, and I think there's some problems that do that for us here. All right, now we have something called STP, standard temperature and pressure. As we get into gases, this will make more sense. But we always take, unless we're told otherwise, that if we're not given this, we assume that our gas is at standard temperature and pressure. Standard temperature is 0 degrees Celsius. Standard pressure is 1 atmosphere of pressure, which is equal to 760 millimeters of mercury, which is equal to 760 torr, which is equal to 101,000 pascals, or 101 kilopascals.